Hey, hello. Today's topic is ionization energy. It is also known as ionization enthalpy. It is also known as ionization enthalpy. Now, what is ionization energy or ionization enthalpy? It is the amount of energy required to remove electron from the valence shell of an isolated neutral gaseous atom. So if we want to write it in equation form, we can write it like this: m, and from this isolated atom we are removing an electron and we are having an ion m plus electron. So here in this case of removal of electron, we need energy, and that means we have to supply energy, del H. This del H value signifies our ionization enthalpy or ionization energy. Now we know that in a chemical reaction, energy can be provided or energy can be generated. Now this del H value, accordingly we will have positive del H value, or we will have negative del H value. Alright, now we know that if the del H value is positive, that means the energy is being absorbed in the reaction, and if the del H value is negative, then energy is being released in the reaction. Now when energy is absorbed, the reaction is known as endothermic reaction. The reaction is endothermic, right? And when energy is released, the reaction is called exothermic reactions. Exothermic reaction. Okay. Now in this case of our topic ionization enthalpy, as we have already mentioned in the definition itself, that the energy is required to remove the electrons, right? We have to supply the energy from the outside. So obviously the del H value for this reaction, in case of ionization enthalpy, the value will be positive. It is always positive, right? So in this case, the del H value is positive. So the reaction will be endothermic. We have to supply energy from outside. Now the unit for del H, the unit for ionization enthalpy, is unit of ionization enthalpy is electron volt per atom. That means when we talk about supplying energy to remove electron from atom, now we know that 1 electron volt is equal to how much? 1.6 into 10 to the power 19 joule, right? So now there is another unit for ionization enthalpy, that is kilojoule per mole. This is the unit for moles, this is the unit for per atom. Now there's a relation between these two units. and that is 1 electron volt is equal to 96 kilojoule per mole. So this is the relation that we have to memorize, we have to cram out. That's all for today. Thank you.